Hey, it's Daniel, Powell Machine, Powell Cams. We are back from PRI. A couple of things. Man, we had an awesome time. We got to meet tons of viewers. We got to meet several other YouTube creators. We got to look at a bunch of equipment and some other stuff that we were interested in, had questions about. And we'll talk about that stuff just a little bit, but the biggest focus of this video is during the second day, Friday, we got a conference room and we had like a Q&A / discussion on camshaft stuff, and I mean, maybe stuff about the challenge, that kind of whole deal. And it was real interesting. And man, a lot more people showed up than I thought would. And there was just a lot of discussion. And there's a few topics I think that need to be unpacked a little bit. So I think we're going to do that in this video. And then we'll talk about some of the other PRI stuff at the end. So hang loose and we'll get into it. All right, so one of the, after kind of just going on with foolishness stuff, one of the first questions was about solids versus hydraulics, and like, if you got a hydraulic and you want to go to a solid, like how does it compare? What size do you need? That kind of stuff. So that question was asked, and Eric asked me to answer that question, and I did. So let's cut to the actual question and the answer, and then a follow-up answer behind mine, and then let's just go over that stuff. So here's the original footage.
Because I want Daniel Powell to get in on this one in a second, but I'll say this: so like if you have a cylinder head that flows really bad down low but really good up top, and you think, well, I'm just going to put a camshaft that's got a bunch of lift in it and I'll make up for it. It won't. It still won't. So it's got to be pretty much. And he cares more about the lower lift than Thule does because of the hydraulic roller stuff. But a lot of my stuff's like solid roller with much more lift, so it's a different story. Like I don't care about 300. I don't. 300 and down, I just don't. Just because most of my stuff's a higher lift. But if you're in a hydraulic roller and you're in a 600 lift world, they're probably more of a play. Now, as far as that cam stuff, I've seen Daniel when he was doing his stuff on his videos, when he talks about the different, what the actual valve movements is, that changes everything. Because, and I know they're not here, and I'm really going to get to you. I like to, anyway, that video that Tony did that just happened last week with the small block Chevy versus the 5.3. I don't know if you haven't watched it, small block Chevy rule. Yeah. But anyway, one of the things that was commented was, well, that's a solid roller, so it had like 15 or so more degrees than your hydraulic roller that was a smaller one. But when you watch the video, the small block Chevy had the 1.5 rocker and the LS had the 1.7. You also have lash in the small block Chevy. So Daniel, I know I've seen him do videos where he shows the actual valve movement, because when you're holding the cam card, you're only holding one part of this equation. So there's way more that happens in between. So if you actually track the stuff like what he does with, I've seen in your videos, tracking the actual valve movements, you'll see that sometimes they're not that far off. They're actually closer, or it could look really close as far as duration-wise at 50 thousandths, but you're not even near. You want to expand on that? Because you do great.
Well, like with solid stuff, people, like when you see a big solid, you think it's big, but it really maybe not so much, because with a hydraulic, there's no lash, and you're multiplying it with the rocker. So at the valve, it takes a lot more solid cam because of lash. And, back in the old days, we had 24 lash, 28 lash, and now people are making ramps much faster and smoother, and we can get down there at 15, 16, 17, so it's not quite so bad. But that's one big deal. But obviously you can move a solid at a much faster rate than you can a hydraulic, just because the hydraulic unit can't take, it's going to bleed. So the advantage to the solid is we can just make it faster. The velocity is faster, so that's where the advantage comes in. But yeah, if you look at a valve motion, you know, it takes a pretty good size solid over the hydraulic to equal a bigger valve motion.
You're talking about a timing number in degrees?
Right, like, I mean, if you got X amount of degrees at this lift interval, you know, a 250 solid and a 250 hydraulic, the hydraulic is going to be a way bigger cam at the valve. It's going to be off the seat much longer. So it might take a 270 at 50 in a solid to equal a 250 hydraulic.
So it's rack arm ratio dependent, and to be very specific about what that difference is, if in the world of an LS, it's a 1:7 ratio rack arm, right? So if you have a 22 to 24 thousandths traditional lash camshaft, the difference between that and a hydraulic roller is 10 degrees at 50 thousandths.
Okay.
So if you have a 230 degree hydraulic roller at 50 thousandths, if you got a 1:7 ratio rocker, okay, it's going to take 240 degrees and a 22 to 24 thousandths lash solid. Now, if you're talking about a low lash, like 10 thousandths lash, it's only going to take about 4 degrees to make up the difference.
Mm-hmm. All right, so, you know, you can see that the question was asked, and then I answered the question, and then the guy behind us, I'm understanding his name is Steve, and he used to be at Cam Motion, and he retired or something. I guess he was an engineer or lobe designer. And so, you know, I said about 20 degrees roughly, and he said 10 degrees at 50, which is pretty close. I mean, that's pretty close. The problem is, here's the problem. We're talking about area. So looking at just 50, and we're going to look at it at the valve, but just looking at 50 at the valve is only 1 point. So you have, I mean, if you got, this example is 264 degrees duration at the lobe, so if you only look at 50, you know, you've got 213 more points to look at. So I think that although at 50, his formula is pretty accurate, I think that looking at the overall area is more important than just 1 point, because there's more going on than just 1 point. So let's start the screen recorder, and then we'll get into what's actually going on here. All right, so we got 2 lobes. This solid lobe, this higher lift lobe, is one of our designs for LS. We got a whole series in this family of lobes for LS. And then gracious enough was Ryan at GPI. This is actually their challenge camshaft. We run it into Cam Doctor and give them a bunch of reports and some at the valve data and all that stuff. So he let me use this lobe, and luckily it's 263, mine is 264. His is, again, we still hydraulic to solid, right? His is 380 lobe lift, and mine is 419 lobe lift. And that's the other deal with a solid, you know, pretty much it's always going to be more lift. A solid is going to be more lift. And if it's not, you just, I'm not saying you're defeating the purpose, but you're definitely leaving stuff on the table, right? So you can see the red is the solid. So you can see how far inside the hydraulic it is. And it only goes outside the hydraulic up here in the peak lift area. So it's got more area up here, but it's losing all this area down here. in the lower regions, and I mean on up to here is like where it starts crossing over. I mean that's 450 lift. So I mean it's well over halfway through its window before it crosses over. So let's look at the valve data for both lobes. So we can see, and this is a little bit confusing sometimes for people, but remember, you know, you can't use @6 at the valve because of lash. So our design, well, we've got it set for 24 lash because the example given was at 24 lash with a 1.7 rocker is 10 degrees difference, and it's not 10 degrees difference. It's actually at 50, it's actually 14 degrees difference. So, I mean, 14 is close to 10, but 14 ain't far away from 20 either. So, I mean, I'm just saying. But the moral of the story is, at the valve, you can use 6, and you should, because, I mean, we start at 0, and we got to go from there. So, 6, 20, 50, 100. I mean, we can use all of those intervals because we don't start counting lift till the valve moves. So even with 24 lash, the valve is still got to come off the seat. So at 6, the hydraulic is 36 degrees bigger than the solid. At 20, it's, what is that, 21 degrees. And you can just see, I mean, even at 100, it's 10 degrees. At 100, what is it at 200? 200, it's 8 degrees. So it's getting better, but it doesn't catch, so the solid doesn't catch the hydraulic till 450 thousandths lift at the valve. It catches it there. So everything before 450 lift, the hydraulic is winning. So, you know, I mean, 10 may be a good number. I think 15 or 18 is probably a better number when you translate. And again, this is a multiplier. So the smaller the cam, the less difference it'll be than the larger the cam. So, you know, something that's 220, I mean, you know, who's got a solid 220, but it happens. I mean, it could happen. But, you know, something down at 220 is going to be a much less spread than at whatever, 260, 270. So, you know, just keep that in mind, that it's not quite as simple as it could possibly be, because there's just variables, you know, the how aggressive the lobe is going to play into that some. You know, like a really lazy, slow solid is going to be bigger download than it would be if it was really fast and aggressive. So all of that's going to come into play, you know, in figuring out what's what. But, you know, again, I think that in the grand scheme of things, 10 to 15 is realistic now that we look at the whole package. But it definitely ain't just 10 and call it a day all the time. It's just not that simple. So, and maybe I can figure at some point here, I'll figure the whole area of the lobe on each one. Well, the whole area of the lift curve at the valve on each one. And then we can have a slightly better comparison maybe. But that's one thing that was talked about that I thought maybe needed slightly a bit more clarification. Another thing that I think is probably worth unpacking a little more is a gentleman, what was his name? Chris Allman. He asked about
tight lash and big lash. And I believe Kip answered this question. And the general summation was big lash beats up parts and tight lash doesn't. And he said it right, but he meant, what he actually meant technically is that high entrance velocity and acceleration beat up parts, and low velocity and acceleration don't beat up parts. So using a feeler gauge number on a valve tip is almost irrelevant, because you could have a cam with a valve lash setting of 12 and have X velocity and acceleration that's perfectly fine, and then have another cam that is 24 lash and have the exact same velocity and acceleration number. Therefore, one has doubled a lash, but it isn't any harder on parts than the one would have to lash. So that's what he was saying. He just didn't say it exactly that way, but that's what he meant. But generally speaking, if you see something, and I have seen stuff with really large lash that the velocity and acceleration is perfectly fine at that lash. And what we do, for instance, we get it all the time where people call and say, hey, I bought this cam from Billy Bob's engine shop and they done ground all the numbers off of it, and I want to know what it is, and I need to know where to set the lash. And we get that all the time. And so what we do is we put it in the machine and run it, and then I can physically look on the lobe and find the correct velocity and acceleration that the lifter should enter. All the slack should be taken out, and then note that amount of a rise, and then just multiply that by the rocker ratio, and now that's your lash setting. And so I always do that for customers, and then there's no question, and that number may be 24 or 26, and that number may be 15. It just depends, how the ramp was designed. And those big long ramps, I'm not saying they're bad or good. I'm just saying that's the way it was done. And you see, it seems like, just from what I see, the longer ramps generally are constant velocity. They'll have a large constant velocity area, and that usually adds to the length of the ramp. And so, it ain't so much because the pickup point is moving up the line. It ain't like a hydraulic. So if you've got a really long ramp on a hydraulic, it's going to make the 6 number really big and make the intensity a big number. But with a solid, because as you tail it out, it's moving up, and it's still, the velocity's still good. You can have a really long ramp and still be okay. It still wouldn't have a large major intensity, and velocity would be happy at that larger lash setting. So, so that, again, I just wanted to just point that out, that that's what we're talking about. That's what he was talking about too. He just said it in layman's terms, which is perfectly fine. But I just wanted to clarify it, because just demonizing 24 lash or 26 lash is not the answer. We need to demonize enter and lift with high velocity. That's what murders parts. And conversely, the same thing on the other side of the lobe, when you set it down, it needs to be nice, slow, and gentle to set it down, because you can't just slam it shut or it's going to bounce. So, so that's that. And then let's do this just to see. Yep. So you can see here, you know, this is oh, that's at the, hold on here. Let me cut this off at the valve. So this is at the cam. So you can see this nice gentle radius. And then some stuff, and I don't have one straight away, I should have had one pulled up, but some stuff you'll see it'll come up out here, and then you'll have a constant velocity area right here, and then it'll come on up. And so usually, not always, but a lot of times when you see that constant velocity area, depending on how long the constant velocity area is, you can usually get into slightly higher lift points where lash is taken up. So that's that. Another thing that was talked about, and I should have probably spoke up and unpacked it a little bit, but I didn't, because I was in the room with all them gurus, and you know, it's make you a little nervous sometimes. But anyway, and I don't remember who, I'll try to find the clip, we'll stick it in here, but the discussion was about, you know, how the test engine made better power with a better head, and or not how, but why the cams swapped places, right? Like in the first test, you know, NK Performance's cam was better than GPI's, and then in the second test, GPI's was better than NK Performance. And so there was, you know, discussion about how that was, and tuned links and cylinder heads and this and that and other thing. And so just to slightly unpack that some, and again, I'm not a cylinder head guru or a header designer either, but we're just making this up as we go. The biggest deal is, and we talked about in the little conference, we should have talked about more stuff, but there was a lot of talk about other stuff. And so there was some talk about, you know, valve events and where, when, and how, and why. The big deal with, so at overlap, so during the overlap cycle, the goal is for the header during overlap to be in a negative wave when overlap happens. So during overlap, we can scavenge exhaust, which helps with pumping losses, just like earlier EVOs help with pumping losses, because anything, again, this is at higher RPM performance stuff, and there is a place where it stops being better, right? But for the most part, the further you, sorry, camera took a dump. So, you know, when all of that's happening, that header needs to be in a negative wave. And so that's done with diameter, length, collector size and length. And so there's there's a lot going on. I mean, I know there's programs and all that, but I still, I mean, like, I can't think of a way that's mathematically possible to, you know, we need a timing light for the header, right? So the header, we need to be able to put a timing light on the header and say, where's that wave at? And the only way I know to do that, and again, it's still trial and error, is with pressure transducers on the dyno, and we can look at the pressure during overlap and then make changes to the header, lengths, diameters, collector shapes, on and on and on, and we're trying to make that pressure in the chamber go down with the header, and that's going to create that negative pressure is going to allow the intake charge to come in easier, right? Less work to do. So that is why when you change a cylinder head or a header or intake manifold, and this cam was good and now this cam is not good, that is why. Because of that whole system has to be tuned together. And that's why when you've got all of these, programs and stuff, and people say, well, my ideal will pick the right cam for your application, the chances of that actually working is very slim, because all of these issues, right? You change one piece and now the system is not optimized anymore. And even, it might have not been optimized to start with, and that's the issue is, it's almost impossible to optimize it without either spending a whole bunch of time at the track swapping parts, or a whole bunch of dyno time or something like that, right? It's really the only way to get all of that worked out at one time. And it's costly, and that's just how it is. But ideally, when me and Kip was just yakking about stuff, and I was like, at the end of the day, really the only way that you could ever make the perfect camshaft for any given package is you would have to start with, and I think for me, the intake valve closing is the most important event in the whole cycle. You got to get that right. And then once you get that right, I think the follow-up event is EVO, the exhaust valve. EVO, the exhaust valve opening. And then you get that nailed down, and then, we can kind of group the other two events with overlap and move those events around with the overlap triangle to optimize that package. And then once all of that's done, now you got the perfect camshaft. But it might take, I don't know, 6 or 7 camshafts to get that done, to optimize all of those aspects. But again, if you want to win races, what's a couple $1,000 on camshafts if that's what it takes to make perfection, right? And the difference between okay and really, really good is, who knows? It depends on the engine, but it might be 10 horsepower, or it might be 100 horsepower. It just, who knows, So, but I still think that, you've got to have, again, if you're going to make it, because it was said in the, I believe Stephen from Cam Motion said it very well. It doesn't matter what you do with the camshaft. If the cylinder head sucks, it's just not going to make power. So you can't fix a bad cylinder head with a camshaft, and you can't fix a bad header with a camshaft, and you can't fix a bad intake with a camshaft. That's just how it is. You've got to have good components if you want to make real power. And, people ask all the time, well, man, tell us how to spec a cam, or tell us how to and again, I say it, other people may disagree, and that's fine, but I'm telling you from all my experience, it's precision guesswork. It is precision guesswork, because I don't know how many times people say, well, they just put some super duper header on the cam recommendation form, and it's not even what they got. And then you design a camshaft around this exhaust system, and they got something totally different. So, and stuff like that happens all the time. Are you in the middle of this build and then it goes this other way, and or this didn't fit and you got to do this other thing, and there's just lots of variables, lots and lots of variables. So there's no one size fits all in my estimation. I think that's probably all. It was super neat meeting everybody from the Cam Challenge. I spent a bunch of time with Ryan from GPI. He's a great dude. We just had a ball talking about engine stuff and cam stuff. And me and Kip talked a long time. Kip owns Cam Motion. Me and Kip talked about all kind of stuff, and we had a good time. Me and Bobby talked a little bit. Bobby from NK. Me and Tooley. Brian was super busy. Brian Tooley was just people. I mean, you can imagine, you know, as big as they are, and they had a super nice booth, and just tons of people was around, just worrying him to death. And we walked by and we stopped and talked to, God, I'm trying to remember his name. The one of the cylinder head guys there. I can't remember his name now, but he was real nice, and we talked for a while, and then Brian got unoccupied with the people he was talking to, and he come over and talked to me and the wife for a little bit, and we had a good conversation about, you know, of course, cam stuff and lobe design stuff, and then we just talked about business stuff, and you know, it was nice. He took some time and we talked, and I appreciated that. And you know, we still 50 people were standing in line to talk to him, so we went on and left him alone. But another thing that I just thought about, the guy that's over the cam stuff at BTR, Nick, I believe it is, he was talking about, you know, like doing whatever, you know, a package on the Spintron and have a problem at a given RPM, and then transfer that right over to the dyno and see the exact same problem at the exact same RPM, you know, and a lot of that stuff is like, we talk about harmonics and surging and valve train weight, and I didn't really know, and Brian told me they did a lot of testing, and like you know, a 5/16 was okay push rod wise, 5/16, and then 11/32 was way better, and then a 3/8 was actually worse than a 5/16 because it's just so heavy. And in the solid world, we don't even worry about push rod weight. I mean, we put, you know, tree stumps in there and pick up 30-40 horsepower, you know, generally on big, you know, like some of the big block stuff we do with 700,000-800,000 pounds of open pressure. I mean, we're running just tree stumps for push rods, and it just keeps getting better because we keep stopping that deflection. And, you know, as deflection starts happening, you'll lose duration. It gets smaller and smaller and smaller as the RPM increases, which is the exact opposite of what you want it to be doing. You would rather it grow instead of shrink. And then not only that, and I wish that we could, eventually we're going to build a Spintron, but that's another thing that I talked to Brian a little bit about with some of the Spintron testing stuff. I would love to see, and I know people's already done it, like it's probably beating a dead horse to a lot of people, but it ain't to me because I haven't actually, you know, hands-on seen it. But the hydraulic lifter, again, I'm spitballing a little bit, but you know, it's like a shock absorber. So as load increases, you know, and you get deflection, and there's air, you know, the oil in the pistons are aerated. And so it's collapsing, you know, as the lift curve is happening, and then it's recovering on the base circle. So, you know, you always wonder how much is it collapsing, how much duration are we losing, and where are we losing it? Is it happening on the opening side, the closing side, where, when, how, and all of that, really interests me. And are some lifters better at controlling that than other brand lifters? So all that kind of stuff, I got lots of questions about that kind of stuff. And so, and then how much, you basic spring package and basic valve, how much difference does, titanium stuff versus steel stuff make? Or, how much difference does hollow versus solid make? And, I got thousands of questions about that kind of stuff. So, so that really, really interests me a lot. And I hope that eventually we're going to get to test some of that kind of stuff, just to answer those questions for me, because it just, I like to know about that kind of stuff. And another thing, while we were there, we was, walking around and just seeing people and this and that and other. We stopped at, and I'd had intentions before, but I just hadn't had time to do it. But we stopped at Your-Dyno's booth, because, we got that old D-Pack system on our dyno, and I want to upgrade it to something super nice where we can see all that stuff on the screen and it looks good for the camera, and it's, accurate and repeatable, and we can do overlays, and, because again, if we're going to do it, we need to do it where it looks good on camera and we can give the data over to you in a way that's nice and professional. So we looked at a system from Your-Dyno with their load control that's much nicer than D-Pack's load control. So I believe that over the winter here, we're going to try to get this thing, the room finished up, and then we're just going to we're going to not wire anything up. We're just going to get everything in, get all the pumps in, and then we're going to buy their system, and we're going to do like 8. I've already got 8 EGTs, and so we're going to add 8 wide bands. And then we've got the air turbine. We got a Superflow air turbine, and they said they could add that no problem. And then, obviously they're, it'll hook up to our strain gauge, and we'll have to calibrate all that stuff. And we're gonna get some really big, nice monitors so we can see everything all at one time. And I should have recorded some of that stuff, but God, man, there was so much going on and so many people. But you can have on their control screen, you can have as many columns as you want to be able to see whatever you want to see, and use as many channels as you want to use. And I thought the price, he gave me a price with all of the upgraded stuff and their load control and the whole deal. And it was really not that bad. I mean, not as bad as I thought it would be. And so hopefully that'll bring our dyno into the 21st century, and we'll have nice quality competent stuff, because obviously that's what we want to do, and we need to be repeatable and all of that junk. So I'm going to make a concentrated effort now that we're not going to do any more engine. Again, I got to finish what we got, but now that we're not taking in any more engine work, I'm going to make a concentrated effort to really try to get this freaking dyno done, because it should have done happened 10 times over. And now that we know we got access to quality data acquisition, it's not going to be a problem, because I've been dreading trying to make that D-Pack stuff work, and hopefully I could just sell all of that. It was working when it was taken out of service, but just, recalibrating it, and if there's any issues, just, you got to find somebody to help you with it and all that kind of junk. It'd just be nice to have something new and fancy and just be done with all of that stuff. So I'm excited about that. But yeah, next year the plan is to go back to PRI, and I think we're going to do a booth, and we're just going to be set up and, you know, have some of the stuff we make and some cams and, you know, all of that kind of stuff. I think it'll be neat, and like I say, we really enjoyed it, and we got to meet a lot of people that we talk to all the time, but we just don't, you know, we ain't never met them, and that was really neat. And I'll tell you, I mean, Eric does a great job, but the person that I seen standing up there in front of everybody talking and going on was a different person than I see on camera in his videos. It's just, I don't know how to explain it, but I mean, he does great either way, but he was just like, you know, just comfortable and just like it wasn't nothing to it. So I really enjoyed it, and he done a great job putting all that together, and it was really good. And we was just, I mean, to me, you know, just being able to sit in that room with all of those professors and gurus, and, you know, here's some 8th grade hillbilly from the woods. I was just honored to even be part of that deal. That I was, you know, that's good stuff. I don't care who you are. That was good stuff to me. I really enjoyed it, and I hope we get to do some more of it, and, you know, hang out with all these smart people and talk and learn more stuff. It was awesome. So if you got questions or anything needs clarifying, put it in the comments. Happy to you know, try to make an answer for it, and suggestions, whatever, thoughts, anything, just put it in the comments. And like I say, all these guys that participated in all this stuff, you know, give them some support when you can, like, share, subscribe, all that junk, because a lot of us have YouTube channels. Oh, I'm just about to forget. So Brent Likens Motorsports, he went to lunch with us on Friday, and we had a good time and talked about a lot of stuff. We've been doing some cams for him. We're gonna do some more cams for some testing and some other stuff he's doing. And Joe Carroll was gonna take us out to supper the first night, but they got tangled up on the bus, because it was pretty nice. We stayed at a hotel near the airport, and then every morning there's a bus every 30 minutes. So, I mean, big old super nice buses that take you from the hotel to PRI and dump you off right in the front door. And then they also take you back, so you just stay as long as you want to stay, and then whenever you get ready to go, I mean, I think the buses don't run from 11 to 3, but outside of that they're running. So you can just get on the bus and they take you right back. And luckily the hotel we stayed in, the Hyatt, it was the first pickup, no, maybe it was the last pickup and the first drop off. So every day when we went back, we were the first drop off. So we'd sit right in the front and we'd just get right off. That was super good. And I mean, the hotel was nice, but all that stuff, man, it's just super expensive. I mean, I think the hotel was like $221 a night. And if you get close, like within walking distance of PRI, I mean, it's $600 plus a night. I mean, it's just insanity. I ain't fixing to pay all that. I'm happy to ride the bus, and it's only like a 20-minute ride on the bus, so it's not a big deal to me anyway. But anyhow, that was just an overview and a few things about the Q&A session. I thought it was a blast, and like I say, this is our first time ever going, so we definitely going back for sure. It was real nice. All right, that's all I got. I'll see you on the next one. Thank you so much. Check out the website, powellmachineinc.com. Drop a comment, like, share, subscribe, all that good stuff. We appreciate you so much. We'll see you on the next one.